Hi everybody, welcome back to another wonderful lesson of Algebra 2. Tonight we're going to be skipping a few sections here. We're actually going to jump forward to section 5.7, which is transformations with quadratic functions. New vocabulary we're going to take a look at tonight is vertex form. So, what's taking place here? Well, we want to be able to write a quadratic function when we're given its graph, or at least a couple points from that graph. That form that we're going to write it in tonight is what is called the vertex form of a quadratic function. This form looks like this. Y equals a times the quantity of x minus h squared plus k. Key variables here, h and k. H and k represent the x-coordinate and the y-coordinate of your vertex. And remember, the way we found the vertex, we learned this a couple days ago, is by taking negative b divided by 2 times a. And remember, by doing that, that is what the x-coordinate was equal to. To get the y-coordinate, I would then take this number, plug it into my original function, and that would give me the y. The a, then, would be a number we're going to end up solving for. The a actually has quite a few properties that can help us out. For instance, it'll tell us whether it opens up or down, and basically how wide it's going to be. So, what are the steps that we need to take here? Well, they are as follows. First step we're going to do is we're going to identify the vertex. The x-coordinate of the vertex is h, the y-coordinate is k, and again, remember, to find that x-coordinate, you're going to simply do the negative b divided by 2a. Step 2, you're going to identify one other point on the graph. You're going to take the x-coordinate, you're going to take the y-coordinate, and you're going to plug this into the vertex form equation. When you plug these in, you're now going to be able to go through, and you should have one variable remaining. That variable should be a. Go through, solve for a, and once we find out what a is, we're going to rewrite the final equation with h, k, and a all being plugged in. Remember, the y and the x, that's part of the equation, so they should be there in the very end. Ultimately, you're looking for an equation that looks something like this. Y equals a x minus h squared plus k, where a, h, and k are all values that we've solved for. Now, again, I mentioned this a couple minutes ago. The reason why we solve for this is it makes graphing a little bit easier. Makes it easier to see where the function lies, where the parabola is going to lie. So if we take a quick look here at this chart, we mentioned here hk was the vertex. And what's nice about knowing the vertex, if you know the vertex, you know this point. And it's simply a translation. So if I know h, let's say h is 3, that means I'm going to take my vertex, which normally is at 0, move it 3 units to the right. If h is negative 3, which this equation would look like then, plus 3, that's going to be 3 units moved to the left. K is then the up and down. If k is positive, that's how many units up we move, and if k is negative, that's how many units down we move. The a that's in front of all of this, that determines a couple things. First off, it tells us which way it opens, which we knew already. A is the term in front of x squared. If it's positive, it's going to open up. If it's negative, it's going to open down. A is also what's called the dilation. It tells us how much the graph is stretched. If a is bigger than 1, it's going to stretch the graph vertically. So what's going to happen is the blue is the original graph. It's going to stretch it vertically, which is actually going to make it skinnier. So it's going to look more like this red graph. If a is somewhere between 0 and 1, then we're going to compress it. So we're going to take the blue and we're going to push down. And when we push down, the ends get kind of pushed out, and it ends up looking like this green graph. So let's give this a try. For this problem here, they're telling me to find the parabola, to write the equation in vertex form, and they're giving me the vertex and one other point. So this is actually not too much work, because if I start with my formula, y equals a x minus h squared plus k, I know right away, by simply looking here at the vertex, that this is h and this is k. So suddenly my equation becomes x minus 1 squared plus or minus 6. Now, I do know one other thing here, and that is I have another point. And this point is x, and it's y. Well, if this is x and y, I can come over here and fill them in the appropriate spots, which means 0 goes for y, 3 goes for x, and the variable that I'm left with, the variable that I'm not going to know the first time through, is going to be that a. But everything else is filled in, which means I can now go through and solve for the missing piece. So I have 0 equals 3 minus 1 is going to be 2, squared to get 4. So 0 equals 4a minus 6. 4a will equal 6 by adding it to the other side. So a is 6 divided by 4, which will reduce to 3 halves. Once I know a, one more step, and that's to write out your final equation. The final equation should have x and it should have y left as variables. So I have y equals a, x minus h squared plus k. And that is the equation of our parabola in vertex form. Alright, let's try another one. Here's the way we have been dealing with parabolas. This is called standard form. Standard form is good for finding y-intercepts pretty quickly, but it's not nice to help me figure out where I need to move my parabola in a quick fashion. So I want to take this, I want to convert it to vertex form, which is y equals a x minus h squared plus k. So I need two things in order to get this to vertex form. I need a, the vertex, and I need b, one additional point. So let's start with the vertex. The way I find the vertex is the x-coordinate is negative b divided by 2a. So for this problem, the b would be negative 2. So if I go negative, negative 2, this is now a positive 2 over 2 times a, or 2 times 1, which gives me a value of 1. Now remember, that's the x-coordinate. To get the entire vertex, I now need to take that x-coordinate, plug it into the original, and see what I get out. So 1 minus 2 will be negative 1, plus 4 gives me 3. So my vertex is located at the point 1, comma 3, which is hk. Now, in order to get to vertex form, I do need one other thing. I need one additional point. So I pick any value of x that I want to figure out what point I have. Now, I like to take the easy route, which means I'm going to plug in 0. And when I plug in 0, I get the point 0.04. That point that I get out, that's going to be your x and your y. So if we go through and we start to plug everything in, I know 4 equals a. I haven't found that yet. X, which is 0, minus h squared plus k. Now we'll solve for a. So 4 equals negative 1 squared is 1, which is just a, plus 3. So a would equal 1. I now know a, I now know h and k, which means my final equation is y equals 1, x minus 1 squared plus 3. And there it is. A couple things about this equation here when it comes time for graphing. Let me make some room. So as far as helping me graph, the a, which is equal to 1, is going to tell me this is going to open up. The other thing that I know is the vertex is at positive 1, positive 3. So if I'm graphing this, right away I know I'm going to positive 1, positive 3, I'm putting a dot. and I know it's opening up. Because my a is 1, if you remember anything about parabolas, if you noticed any patterns, and I didn't really talk too much about this, but if you notice the pattern, it was 1 over 1 up for these 2 points, and then 2 over 4 up for the next 2, which meant my parabola is right here. So if you can see, this form, very, very helpful when it comes time to graph. You don't have to worry about making the XY charts. It's a lot quicker, it's a lot smoother, it's a lot neater. Alright, so let's give one more try here. Last example, this case they've given me the graph, and I'm trying to write the equation of the graph shown. So, here is my formula that I'm looking for. And first thing I find right away, my vertex. There it is. The vertex is located at positive 2, negative 3, which is your h comma k. So this becomes x minus 2 squared minus 3. Now, I have to find a. Well, I need one more piece of information, so I need one more point, and I can pick any point that I want, but again, I want to make it easy on myself. So let's go with this one, and that's the point 0, negative 1. So if I take those, and I plug them in for my x and y, this now becomes negative 1 and 0. Solve for a. Negative 2 quantity squared will be 4. So 4a minus 3, which means 4a will be 2, and a will be 1/2. Once I know the value of a, we write our final equation. Y equals 1/2 x minus 2 squared minus 3. And this is a parabola whose vertex is at positive 2, negative 3. Positive a for our equation, which means our parabola is going to open up. And since a is 1/2, it has actually been compressed vertically, so it's been pushed down and made a little bit wider. Please give 5-7 self-check on Moodle a try tonight. Bring your questions in tomorrow to class, and we'll do some more examples. Have a great night.